Montgomery. Yeah, I know Montgomery.
Okay. So if I have, let's say, a particular IN, which
Let me
is
can
equals
focus
to
along
integral
about Macaulay Road now or at Adekule.
from 0 to pi over 2.
So
I'm having a feeling I've talked about this one before, but I don't know.
Yes, you can
Thanks
focus.
so much.
So let me use sine for example. It's Have I not talked about
So
what this
said
formula before?
to pass on the
Okay. When you said where was the person, you said traffic is
Are
from
you sure I'm not
now.
talking about? I've not
said
talked
it's
about
not
what this
going
formula
on
before.
because I'm not sure about traffic.
Can you hear me?
So after that, like, three is a door that we use the
Hello, can you hear me?
I didn't have question.
So I'm just surprised that I've not
This
talked
guy
about
is
what this
the only
formula and I talked about
guy.
reduction formula. Are you sure we have not talked about what this formula before? You said? I said, are you sure I've not talked about what this formula before? Oh, I didn't get that. What did you say? I think your network is kind of bad. I don't know. So, so, uh, so if you have integral of this form, you are trying to find a form. You know, this is a definite integral. You're going to get a certain value by the time you find the limits from 0 to pi over 2. Now, this is dependent on the reduction formula. So let's say what's the reduction formula for sine x is per n. So without wasting our time, I don't need to do the reduction formula from scratch again. So I don't need to do it from scratch again. So I would say is equals to so let me see the reduction formula. The reduction formula for
The old one is still here, but she's the resident account.
the reduction formula for IN.
Yes. You get the major accountant is the consultant.
For IN. So is what? I'm sure I've talked about this. I don't know why we are doing this again. We have done this now. Now I said when n is even and when n is odd. So IN is a particular value.
Straight with civic high.
Do you remember?
See with NG of Facebook building. Yeah, it's also on the
But
same
what?
street. Yeah, Polaris Bank. Yeah.
Your network is bad. Can you send me a text message on WhatsApp?
I don't like pushing.
So
Better tell you, close mouth is a close destiny.
I don't know.
Was that not how you
So
post in chat?
I know I've done this, so I don't know why we are doing this again. So without wasting much of our time, so I will just erase this guy. IN. So IN for this guy is now given as n minus 1
Called me twice.
multiplied by n minus 2, n minus 3 rather.
You
Then
know what I did?
dot
Immediately we got the better.
all over
Just so that you know your friend happy.
n times n minus 4, sorry, n minus 2.
All of you should saw.
Then dot. This one I keep reducing by 2 also. So the numerator and denominator we keep reducing by 2 times p. Now the value of p is different when n is odd and when n is even. So when n is odd,
You should just shock off and say no virtual.
when n is odd, when n is odd, p is equals to 1. P is equals to 1 when n is odd. And also when n
still busy?
is even, when n is even, p is equal to pi over 2. P is equal to pi over 2. So this is the same when you have cos instead of sine. So this logic is the same thing. So when you have cos, so it's still the same result. So for example, if I'm told to find the integral of from 0 to pi over 2 of let's say sine x power 5x dx, I'm told to find the integral of this guy. Since I already know the Wallace formula, which is this guy, whether it's sine or cos, so I will say, I will specify that, okay, in this case, my n is 5. So here I will say I'm evaluating I5. So I will say I5 is equals to 5 minus 1 multiplied by 5 minus 3. If you keep reducing by 2, now I cannot write 5 minus 5 because if I write 5 minus 5, I'll have 0. So you will stop at 5 minus 3 here. Then also divided by 5 times 5 minus 2. Then this keep reducing by 2, that's 5 minus 4. Now I cannot do 5 minus 6. I won't do 5 minus 6 because 5 minus 6 is negative, so I will stop at 5 minus 4 here. Then multiply by p, and my p in this case is going to be 1 because n is odd. So because n is odd, that's why my p is 1. So this is going to give me hold on, sorry, wait, hold on. So since n is odd, my p is 1, so 5 minus 1 is 4. So I have 4 times 2 all over 5 times 3 times 1. Then times my p, which is 1. It's not necessary. So this is 8 over 15. So this is going to give me my value of my question here. So this is going to be the result of this question. Now, some cases you might find a question like this. Integral from, let's say, 0 to pi. They won't give you pi over 2 as the upper limit. So let's say I have something like this. Sine, say 7 is per, sine x is per 7 dx. So in this case, you have to convert this upper limit to pi over 2. So how do you go about it? So this is going to be integral from 0 then pi over 2. So if you are dividing this by 2, you have to multiply by 2 in this manner. Is that?
Okay.
So you have to do, if you are dividing the interval by 2, you have to multiply by 2, then you have sine 7 x is per 7 dx. Now, in this case scenario, this is going to be your in without these 2. So this is going to be your in without the 2. So the result you get, you're going to multiply by these 2. That's going to be your final answer. Now, another scenario you can have is something like this. I can give you something like this. Say integral of minus pi to pi. So you have to know how to move from this kind of limit to something that is going to be suitable for you to use the Wallace formula. So if I have something like this, so what I'm going to do here is that, your Wallace formula is 0 to pi over 2. So how do I make this one to look like this, something like this? So in this case, let me rub this part. So in this case scenario, if you have something like this, you are going to split this interval into 2. Now, if I go from minus, like if I say minus 2 to 2, for example, minus 2 to 2. If I'm going from minus 2 to 2, I will get to a point 0, right? So in this case also, this interval, I'm going to split it like they say minus pi. So I have minus pi to 0 plus integral 0 to pi. So instead of me doing minus pi to pi, I'll first of all do the integral of this from minus pi to 0, then add it from 0 to pi. It's still the same thing. You understand? Okay, like if I want to kind of tweak this guy now. So if I want to tweak this guy, so the one I have issue is basically this guy. And to do this guy here, what I just need is what divide this by 2 and multiply by 2, right? So, but in this case, how do I deal with this guy? How do I deal with this guy? So here I'm going to first of all, I want to make this guy something like this. So this part, I'm going to, if I switch the interval, I have 0 to minus pi, like this. I have to put minus sign here. So I split the interval this way. So plus integral from 0 to pi. So this I can make it like pi over 2 and times 2. Now I still have issue with this guy. But okay, at the same time I can say okay minus integral from 0 to, okay, let me put minus 2 and let me put okay minus pi over 2 here, right? That's for this part. Then plus 2. So I didn't write anything here. You are going to put this sign x is per 7 inside this place to complete it. So I'm just putting the interval because that's what we need to deal with first. So this is going to be 0 to what? Pi over 2. Now the next thing I have to deal with is this this minus pi over 2 of a thing. So how do I deal with this minus pi over 2? Because I need pi over 2, not minus pi over 2. So this is how it is. So this how am I going to do that? So I have, just like logically it's a function of x. So you are trying to say that what you're trying to say here, forget this minus 2 that is here. What you're going to say here that your x takes value between 0, so let's say 0 less or equals to x less or equals to minus pi over 2, right? So you are trying to say this. How can I make this guy positive? What I'm going to say is that what I'm going to do is that if I multiply this inequality by minus sign, it means I'm going to calculate like this. I have pi over 2 greater or equals to x, and what? Greater or equals to what? Equals to 0. Right? So okay. So in that case scenario, I can do something like in fact, I don't even need all this stress. But I'll tell you, I just want to give you a brief or the logic behind it. So this is now, this one now is going to become minus 2. So I'm going to have 2 here. Then I'm going to have pi over 2 here. Do I have pi over 2? Pi over 2 here. Because I've changed the interval now to this guy. So this one actually means 0 less or equals to x less or equals to minus pi over 2. But this one, don't mind this guy. This guy might look like it's stupid. Though it's actually stupid because the reason why I say stupid is that is 0 is never less than minus pi over 2. But let's just forget about that part. So actually what I'm just supposed to do from here is that, so without loss of generality, what I'll just say from here, from this place, From this place I am like this part. By the time I come down here, I'll just say this is equals to minus 2 integral from 0 to pi over 2 without changing anything. 2 integral 0 to. In fact, what am I even saying? What am I even saying? I just missed something now. So I just missed something now. So I don't need to go this far. So let me erase this first. Now it depends what you have. So let me erase this. I will tell you the logic you are going to use. From here like this. Are you with me?
Yeah.
If you have integral of a function going from minus c to c, that is like this case minus pi to pi. Are you with me? So if what you have inside this function is an odd function, you don't need to do any integration by part or any integration at all. Just say that the answer here is equal to 0. So all you just need to quote is a theorem that if I have integral from minus c to c of f of x dx and so you say if this is equal to this and f of x is odd and f of x is odd, then you can say that integral from minus c to c of f of x dx is 0. Else, if f of x is even, then integral from minus c to c of f of x dx is equals to 2 into integral from 0 to c f of x dx. This is the case if x is even. I'm going to have this. But if you have this case whereby f of x is odd, then this guy is going to be equal to 0. So for this case, sine is an odd function. So sine is an odd function. And since sine is an odd function and I have integral from minus pi to pi, the answer is going to be 0 without wasting much of our time, without loss of generality. This is going to be equal to 0. So if you have doubts, let me try and prove that for you and you see what I'm talking about. So what's an odd function and what's an even function? Okay. So I will say f of x is odd. F of x is odd if f of minus x is equals to minus f of x. So f of x is odd if f of minus x is equal to f of x. And let me erase this part also. And f of x is even if f of minus x rather is equals to f of x. Is equals to f of x. So the reason I said f of sine x is odd is because if I should do sine minus x, sine minus x is the same thing as minus sine x. Which corresponds to this condition that is here. But cos is an even function because cos of minus x is actually going to give you cos x. It's going to swallow the minus. So you can prove that with your calculator with any value of x. So now to prove this valid point that if f of x is odd, this guy is going to give you 0. That if f of x is odd, this guy is actually going to give you 0. So let's put it to the valid a valid example. So I will erase this guy. I hope you are writing. So I'll put this guy using this using sign, or I'll use sign. So let's say integral from minus c to c. I don't need to use any value. Let me just use minus c to c because it's general. So let me say integral of sine x dx from minus c to c. And since sines are not function, this is supposed to give us what? 0. So now what's the integral of sine x? That's minus cos x, right?
Yes.
So I'll take the limit from what? Minus c to c. Now if I should put c as x, I'm going to have minus cos x, right? Sorry, minus cos c. If I put c into x, right? Then minus cos. Put x as minus c, I will have cos into minus c. Then close the bracket. Now this is going to give you minus cos c. Minus cos c. Minus times minus is plus. Now cos minus c is the same as cos c. And minus cos c plus cos c is what? 0. So this is a trivial case to prove that this is actually true. So I'm going to use another case study again. So I'm going to use another case study for you. So let's use another case study. So let me use, for example, integral from minus c to c of let's say 4x cubed. So 4x cubed. 4x cubed is an even function. It's an odd function. Why? Because of the power of x, which is 3. Because of the power of x, which is 3. So if I should integrate 4x cubed, okay, this is going to give us x is power 4, right? So if I substitute limit from minus c to c, so when x is c, I have c raised power 4, right? Minus, when x is minus c, I have minus c raised power 4. So this is going to be equal to c raised power 4 minus c all raised power 4 will give us what? C raised power 4, right? So c raised power 4 minus c raised power 4 is what? 0. So whenever you have this scenario and you have your function of x to be an odd function, you don't need to do anything. Just say that this answer is 0 and state this theorem. That's why this is actually 0. So you can meet this kind of question in competition. They'll just give you one huge function. Yeah, you're not put minus c to c. You're not say, oh yeah, integrate. You just see like where do I start? Where do I start? You not see. So you not see the function you are taught to integrate. You not see the lower and upper limits. So you already will not be. You be taking straight. So you just start integrating. Then maybe after 45 minutes, you just like you just get 0. So all the skills I've been doing since because of 0, I want to get. So let me give you a scenario. So I can be so wicked, and for competition, I want to give something like this. And I'll give, okay, integrate. So let me raise this. And I'll give something like this. Say integrate from minus 2016 to 2016. I'll give you something like this. Of I'll now put something like sine raised power 2018 of exponential 2x squared. I'll be so wicked to give you something like this. Dx that you integrate. Now if you don't know the logic behind this thing, you start about thinking of how you want to start to integrate this thing. And all you just need to say, this is actually cos 0 because sine is an odd function. Then you state this theorem. So it happens like that. So I can show you one question like that. So let's this. Let me pass for you. I don't know if I have this question in mind, but all those MIT integration B questions. So I'll show you. I'll show you one. MIT integ. I don't know the year. Maybe 2019. Maybe 2018. So let me check 2019. So let me check this one. Please send me right. I don't want to download. So let me show you one. So which one is this one? I don't want to see the questions. I don't want to download it. Let me check 2019, for example. This one will tell me to download. Okay. So let me go to, let's store it on document. Or let me go to music and store it. First of all, let's do 28. So let me do 2018. So let me do 2017. I think up to 2016, maybe I should be able to pick that question from it.
So, all right.
And 2016. 2016, yeah. So let me go to music and open that stuff. See, music. So let me start. I was only on music now. I wasn't on music. So let me refresh. Didn't I use music to download this stuff? Let me check download. Let me check download this one.
You might fight too.
It's not in here.
Okay, exhausted.
But I think I used
They give you work.
it's already existed on my where is it now?
So which work?
You know where it went to, because I can't see it. It's not here. It's not down. But I changed it from documents. It shouldn't be here.
You invite see.
Okay. Okay, let me open it this
So what
way.
do you do for the GT guys?
So let me just use the answers, for example. So,
Women are playing
2016.
everywhere now.
Okay. Let me open this guy. Let me check 2016.
Inactive. I'm person is doing it on purpose. Not blessing actually. It's his body that is doing it on
So
purpose.
2016. This.
Yeah,
So look at this scenario now. Look at this scenario. Are you seeing this? Are you seeing this? Are you seeing this?
Yes.
So look at this example now. They gave integral from minus 27 to 27 of arc sine x raised by 1 over 3
Richard,
over 3 dx. And after you to integrate. Now, if you don't know that theorem, you start to integrate this guy. You start cracking your head trying to. All you just need to equate this guy to the answer is 0, and just state that theorem, and that's all. So you can see that integral from minus c to c of arc sine of this. Sine is an odd function. So it's sine as an odd function, arc sine is also an odd function. So you just need to state that theorem.
it's a big
Instead of having to do this. So all these things are basic, they are level 1 integration questions. So maybe you can try to play it with it someday. So I don't know whether I still let me check 2017 for example. I don't know whether this one has something. This 2017. There's one particular one I'm really looking for. It's not here. Let me check 2018. This 2018. I think there's one particular one I'm looking for. Let me check 2019. There's one particular one that is like that is somehow
This is how we
maybe
here.
maybe what is it?
Yeah, they're all.
I don't think so. I think I found what I'm looking for. So it's not something like this. So that's just it. So that's just it. So moving on. Now so also so that's for reduction formula for sine and cos. Now for multiple functions like product of two functions. So let's say for example you have im comma n which is equals to integral from 0 to pi over 2
Knowledge is my load.
0 to pi over 2 of sine raised power mx cos raised power nx, for example. So what is formula for this guy? I didn't kind of physical class. I would have proved this guy for you. First of all, I will just have to. So you want to prove this guy, for example, you don't have to go to the stress of trying to prove the reduction formula, then trying to show the Wallis formula. So just say recall that if you know the reduction formula in your head, like you know it up and just state recall that reduction formula for imn is equal to this, then start using the limits to validate the Wallis formula. So the Wallis formula for this is equals to, so you have two variables, two powers, m and n. This is equals to m minus 1. It's just similar to that of sine and cos. It's just that this one has two variables, m and n. So m minus 1 times m minus 3, then dot continues. Then you do for n minus 1 times n minus 3. Then you put dot also all over. So all over m plus n times m plus n minus 2 times m plus n minus 4 plus m plus n minus 4 dot times 4 times p rather. Yeah. Now, so what is the condition for our p here? So p is equal to pi over 2. So p is equal to pi over 2 if and only if. So if and only if. So that's what this IFF means, if and only if both m and n are even. If it's pi over 2 if and only if both m and n are even. So otherwise p is equal to 1. So otherwise, so you can see that I'm not looking at any book as I'm doing this thing. So it's very simple. It's very simple, just for you to understand the concept. So otherwise p is equals to 1. So what do I mean? So if both m and n are not even, then p is 1. Unless both m and n are even, that's why you have p to be pi over 2. So if m is even and n is odd, p is 1. If m is odd and n is even, p is still 1. If both of them are odd, p is still 1. But it's only pi over 2 when both of them are even. So now in this compared to this scenario that I gave now, this one that you have integral from minus c to c of a particular function f of x. So if we have it for this kind of scenario too, say integral from minus c to c of this kind of product function, it will also be equal to 0 because you have an odd function multiplying an even function, and the product of an odd function and an even function is an odd function. So let me state that. So So it's only so when you have even function, so if you have even function times even function, you have an even function. Also, if you have odd function times odd function, you have an even function. So if you have odd function times an odd function, you have an even function also. But when one of them is odd and the other is even, then you have an odd function. So in this case, the product of these two is an odd function. So if you integrate from minus c to c, the result is just going to be 0. So you don't need to do anything at all in this case. Okay. So let's do an example on this guy. So let me go put this part and just come to this guy. So let's say we are given that minus, so you should integrate, let's say sine is per 7x, then cos is per 5x dx, ranging from 0 to pi over 2. So all you just need to use this formula since I have this one. And this guy also can come in another format. It can come in another format. I can't just I think. Okay. Let us discuss about this one. When you get to year 3, doing mass method 3, we talk about that. That's when it's going to lead to what we call talk about gamma function. So for now, let me just stick to this. So so here we just state that our n is 7 and our n is 5. So our n is 5. So using this formula, I have 7 minus 1, 7 minus 3, 7 minus 5. I won't get to 7 minus 7 because I have 0. So I'll stop at 7 minus 5. So also, I'll do 5 minus 1. So 5 minus 1 times 5 minus 3. I won't get 5 minus 5 times 5 minus 5. So it's 5 minus 3 rather. All over n plus n, which is 12, times 12 minus 2, which is 8. So 10. Times 12 minus 4, which is 8. Times 12 minus 6, which is 6. Then you go to 4, then you're going to stop at 2. That's 12 minus 10. You're not going to do 12 minus 12. That will give you 0. So you're going to multiply this by p, which is what 1 in this case, because both of them are odd. So you're going to have this to be 6 times 4 times 2 times 4 times 1, 4 times 4 times 2. Yeah. All over 12 times 10 times 8 times 6 times 4 times 2. Yeah. Times 4 times 2. You multiply this by 1. So 4 and 2 cancels 4 and 2. 6 cancels 6. 8 cancels 8. So I have here to be 1 over 120. So my result for this this is 1 over 120. Right? Does that make sense to you at all? All right. So I think basically I've covered Wallis formula, right? I didn't get that. What did you say? Okay. So what are we supposed to talk about today now, this week now? I think, so let me check. We did derivative last week. So so let me see. Pictures. Okay, I said pictures.
To make it VIP.
So let me check. So what's next? What's in chapter 4? Let me ask you. What's in chapter 4? Okay, hyperbolic functions. Yeah, hyperbolic
We
functions.
can't hear you.
But do you want to see my face? But do you want to see my face? So she doesn't want to see my face. So
But are you sure?
someone is asking that, are you sure? Okay, sorry. Let me show someone's face for you. So, I hope this is clear.
Of course, your computer.
Wait, is it showing? Okay.
This is terrible.
Oh, sorry.
How's that? Wow.
Don't break my computer now. So this
Don't talk. She knows.
okay.
Hello. Can't hear me.
She can hear you now.
What do you mean? I can't hear you. I can't hear.
Pelumi, can you hear me? Okay, you can identify the face that is behind me now?
Why are you shouting? Why is your camera not good?
It's the reflection of the lens.
Your camera is not good. How are you feeling? How are you? Right, I just wanted to check up on you and say, and I'm sorry for taking Emmanuel away the other day. Mabinu. Yeah, thank you for understanding.
All right, so moving forward. So here in this guy, I have this question. So I have this question. Where's my book? So you are told to solve this question.
The other day, I remember doing this.
To solve this guy,
I remember.
to solve 3 cos theta minus. So I'll do number 1. I'll do number 3. Okay. Should I do number 3 or should do? So let me do number 2 too. So let me do number 2 too. So I'll do 1a. I'll do 2. Say if theta is equal to ln. Is it supposed to be theta? So let's see how it goes. Now say tan theta is equal to minus cos 2 theta. I'm having a feeling that there's something on this question, but so the third question says find it in logarithmic form. You have a textbook with you, right?
Yeah.
So find the logarithmic form of find in logarithmic form the value of x for which cot x, that's hyperbolic cot, is equal plus 2 is equal to 0. So let's start from question 3a. So let's get started. So let me erase this guy. So we are going to solve this guy. So I'm going to solve this guy. That's 3. Wait, what do I have again? Is it 3 cos theta? Yeah, 3 cos theta. Okay, 3 cos theta.
Now change it
3 cos theta minus sine theta. And sine theta is equals to 3. So how do I solve this guy? So the first thing I'm going to do is that, how do you solve this guy? So I have to in mind that, oh, this thing is going to be this to solve like a quadratic equation. So how do you, so for you to be able to solve this guy, you don't have 2 equations, just have 1 equation. So how can I make everything to be cos theta or sine theta? So I can now make all of these things to be cos theta or sine theta. I have it at the back of your mind that cos square theta, that's hyperbolic function, that cos square theta minus sine square theta is equals to 1. Do you know this?
This thing is
So if I should take this minus sine theta to the other side, I'm going to have 3 cos theta. So 3 cos theta is equals to 3 plus sin theta. So I have something like this. So what I'm going to do is that I'm going to square both sides. So if I take this one to the other side, I'm going to square both sides. So I'm going to say this squared is equals to this squared. So I'm going to have 9 cos squared theta is equals to 3 plus, no, what am I writing? Not 3 plus. That would be 9 plus 6 sin theta. 6 sin theta plus sin squared theta. Do you agree? So looking in this way now, the only way you can convert this thing to all cos or all sin is that, look at this. I already have sin theta. I already have sin squared theta. So to relieve me the stress, you just convert this one to what? To sin. So you just convert this one to sin, which is this guy, which is this cos squared theta. And for my identity here, cos squared theta is going to be what? 1 plus sin squared theta. So I just have 9 into 1 sin squared theta. So I'm going to have 1 plus sin squared theta here to be equals to 9 plus 6 sin theta plus sin squared theta. Are you trying to say something? Plus sin squared theta. Now I can now take like everything to the other side. So I will have, this is 9 sin squared theta. Then by the time I take sin squared theta here to the other side, I have 9 sin squared theta minus sin squared theta. So I have 8 sin squared theta. So I have 8 sin squared theta. So people around there, they are not comfortable with you I'm calling these things. So because they don't like calculus. So it used to happen like that. So 8 sin squared theta now be equal to, so not equal to. So by the time I take 6 sin theta to the other side, I have minus 6 sin theta. Right? Then I have, so this is 9. By the time I take 9 to the other side, I have 9 minus 9, which is 0. So I have this to be equal to 0. Right?
Yes.
Okay. All right. Okay, so the next thing I'm going to do is that, what's common to both sides? Sin theta. So no. That's 2 sin theta, right? So I'll take 2 sin theta into bracket 4 sin theta minus 3, right? Is equals to 0. So if this times this is equals to 0, it implies that 2 sin theta is equals to 0, or 4 sin theta minus 3. You guys should go away now if you are not comfortable with what I'm saying. 4 sin theta minus 3 is equals to 0. So that implies that what? Sin theta is equals to 0. That implies that sin theta is equals to 0, right? That's 0 over 2. Or sin theta is equals to 3 over 4, right? So your theta here is going to be arc sin. That will be arc sin 0. That will be arc sin 0. So you can use your calculator to find this. So arc sin 0 is actually 0. So
your friend said
theta
theta is equals to
this thing. Your
So theta here is going to be action
your life. I'm like
3/4. So so you can use calculator to find this. All right, now.
quite easy to fetch him out.
So this part is it clear? Is it clear? Can I move to the next part?
This is like
All right, very good. So so this.
yeah.
So let me just remove this. So okay. So I just use this. So the second part of our question is saying that if let me see it again. If theta, I'm having a feeling that this question is kind of wrong. I'm having a feeling that.
Are you a realtor, Toby?
Let me see the question again.
That's what you are.
If theta is equal to ln theta, then tan theta is equal to minus cos theta. So this is wrong. So I think the question is supposed to be if phi. So let me use phi instead of theta. So if phi is equal to let me check again. Is equal to ln. Is equal to ln tan theta. So if phi is equal to ln tan theta.
You should be proud of it.
Ln
everything. We all do it.
Ln tan theta.
Yeah. So don't be
So
shy.
if phi is equal to ln tan theta,
I can't tell you.
then this is what to prove. We want to prove that tan phi, I think it's tan phi. Tan phi is equals to, use the SQL, minus cos 2 theta. Cos 2 theta. This is tan phi.
I hate phi.
So so how do we move from this guy? So the problem is how do I move from this guy to prove this guy? So how do we move from this guy to prove this guy? So so looking at this, we're like math stuff. So how do you go? So so what should I do like this now? What should I do? So I can do something like this.
This is very easy.
Now find it.
So what do I do? So if phi is this guy, she can hear what you're saying.
You shouldn't be fine girl. Paloma, you know you're fine girl. I say you're a fine girl, Paloma.
Hey.
I know.
So how do we how do I prove this guy now? I'm finding that there's something I'm missing out in this guy.
You're meant to understand.
So no, this is, wait, is this tan or tan? Okay, ln tan theta. Okay, ln tan theta.
Yeah.
So let's start from here. We have that phi is equals to ln. Please, you guys should go outside. Ln tan theta.
Like my food daughter. Actually, she's smart.
So this is, we have this guy. It's okay now.
You will not pay for it.
And
you
we
will not
could
pay for subscription. You will not pay for it.
Oh God. So okay. So take exponent of both sides. So we want to remove this ln from here. Are you with me? Balumi? So if I take exponent of both sides, I have exponent phi. I have exponent phi. The way I'm writing these things somehow. So that will be exponent phi.
How is that taking care?
Is equals to what? Is equals to tan theta, right?
So you very well for everyone. That's good.
Are you with me? Right? So if I should take the inverse of both of them, if I take the inverse of both of them, I will have exponential minus phi to be equals to sec theta. Do you agree? No, not sec. Not sec. Cot theta. Cot. So this is what I mean. 1 over exponential phi is going to give me exponential minus phi is equals to 1 over tan theta, which is cot theta. Do you understand? Okay, and this is where I'm going. I'm going to this place. Now recall So we call that. Sorry. So we call that cos phi. I'll use phi in this case. Cos phi in exponential form is exponential phi plus exponential minus phi all over 2. Do you agree?
Yes, sir.
Y shine phi is equals to exponential phi minus exponential minus phi all over 2. Okay, so we say, let's say this in memory. Let's say this in memory. So if I do this, divided by this, what am I going to have? I'm going to have tanh phi. So that implies that tanh phi will be equals to exponential phi minus exponential minus phi all over exponential phi plus exponential minus 5, right? Right? So now from where we stopped here. So we stopped here. So let's now do exponential phi minus exponential minus phi all over exponential phi plus exponential minus phi. Why am I using theta instead of phi? So let me move this. So all over, so phi exponential minus phi exponential minus phi. So using tan theta and cot theta to replace exponential phi and exponential minus phi, I'll have tan theta minus cot theta, right? All over tan theta plus cot theta, right? And don't forget that this is equal to what? Tan phi. This is actually tan phi. So let's put that at the back of our mind. And where we are going to is to prove that this is equal to what? Minus cos 2 theta. So moving on from here. So what do I do? What should I do? Should I divide both sides by cot? Should I divide both sides by tan? So how do I get minus cos 2 theta? So how do I get minus cos 2 theta? Okay. So let's try and write everything as sine over cos or cos over sine. So this is sine theta all over cos theta, because tan theta is sine over cos, right? So minus cos theta all over sine theta. Also, this is all over sine theta all over cos theta plus what? Cos theta all over what? All over sine theta. If you don't go outside, I'm gonna make that fun. So if I simplify this numerator, I will have sine square theta minus what? Cos square theta all over what? The LCM is what? Is cos theta sin theta, right? Right? Benumi, are you there? Then everything all over. Simplify this denominator too. I will have sin square theta plus cos square theta
No big deal, I just come out.
all over
I don't reach out.
cos theta sin theta. Are you with me? So here, this one is going to cancel this one. Do you agree? What do you say? Do you agree? Okay, so let me erase this part and continue from here. So this is now equals to, so this will be equals to sin square theta sin square theta minus cos square theta all over what? Sin square theta plus cos square theta. Don't forget that sin square theta plus cos square theta is what? Is 1. So I have sin square theta minus what? Cos square theta. Right? And this is minus into bracket cos square theta minus sin square theta, right? If I factorize minus from this one, I'll have that. So what is inside this bracket is actually what? Cos 2 theta. So this is equals to minus cos 2 theta. So that has helped us solve this what? This problem. Do you understand? Okay, beautiful. I didn't know it would be this fast. So so moving on to the last question that I have here. So let me erase. Can I erase this?
Yes.
Okay. So so the last question I have here is, or the next question, let me put it that way. It's a find in logarithmic form. So I'll just say find in log form. Find in log form. The value of x. The value of x. The value of x for which hyperbolic chord of x is equals plus 2 is equals to 0. So how do you solve this problem? Now solution. So if you have this kind of question, the best thing is that you are going to write your chord or whatever hyperbolic function, write it in exponential form. So doing that, I'm going to have cot x is just exponential x plus exponential minus x all over exponential x minus exponential minus x plus 2. But let me just say it's equals to minus 2. So let me just take the 2 to the other side. Are you with me?
Yeah.
So let's cross multiply. Let's just cross multiply. Then I'm going to have exponential x plus exponential minus x is equals to minus 2 exponential x plus 2 exponential minus x. So if I take this one to the other side, I'll have 3 exponential x minus exponential minus x, yeah, is equals to 0, right? Now, let's multiply through by exponential x so that this one will become 1. So if I multiply by exponential x, I'm going to have 3 exponential 2x minus exponential minus x times exponential x. That will give me exponential 0. So that's 1. So minus 1 is equals to 0. So from here, I'm going to have exponential 2x. I can make exponential 2x the storage of the formula is equals to 1 over 3. Do you agree with me? So this is like you are saying that should I put it this way? So I can put it that way. So I'm actually saying exponential x all squared, exponential 2x times exponential x all squared. So this is equals to 1 all over 3. So it's like a quadratic form, a quadratic expression. So let me erase this part. So here I can say that. So here I can say that if I take square root of both sides, I'm going to have exponential x to be plus or minus 1 over root 3 because it's going to have 2 roots. So let me just write this one very well. So exponential x is equals to this. Are you with me? So I'm not going to consider this negative value. Now this is only valid for positive value because I'm going to take ln of both sides, and there's no ln for a negative value. So there's no ln of a negative value. So if I take ln of both sides, so I'll say taking natural log as ln of both sides. I will have x. So ln of exponential x is going to be x is equals to ln of 1 over root 3. I'm not going to consider minus 1 over root 3. So I'm going to have this. So here I can say this is now equals to maybe ln 1 using law of logarithm. Ln a over b is ln a minus ln b. So that will be ln 1 minus ln root 3. And ln 1 is 0. So I have 0 minus ln 3 raised by half. Right? So this is going to give me minus half ln 3. So these are answer in logarithmic form. So very basic. So now let's solve one more question. So let me go to this 4.1, 4. So let me check this. First, find the first and second derivatives of the following. I think this is very trivial. Just take ln of both sides. I don't think you should have any issue with this. Or do you have any issue with that? Take derivatives, just derivative. You said? What did you say? Okay, you can look at the question and feel like, okay, maybe there's one particular one you think we should go over. So maybe you should be the one to choose now. Yes. So which question should we try to attempt before we round up to the discuss? So you can check a textbook. Is it 4.2? Should we go to 4.3? Or is there a question in 4.1 you think we should attempt and go over it?
There's no cloud. It's just one lesson.
Exercise 4.3.
You said 4.3.
Yes.
So which number? Which number are we talking about? Number what is that?
Okay, so you just understand.
Number 8. Number 8.
Okay, yes,
Yes. Yes.
Okay. So let's see how far we can go with this number 8. So let's see how far we can go with this number 8. I hope you have. So say let y to be ln sec x plus ln tan x, and absolute value of x is 5/2. Show that. Okay, maybe we can do the first part and continue the second part in the next class. So let y to be ln sec x plus tan x when x is absolute value of x is less than 5/2. Show that
Don't tire me.
dy over dx is cos y. So show that this. So let's start with that first. So let's start with that. So let me erase this.
What do you mean is well?
So let me erase this guy. Say
I don't have rights to completely. I don't permit to the community to say, and she slightly.
so.
Oh, she even traveled because she did not see mother. So before she came, I brought her the stuff.
So given that y is equals to ln sec x plus tan x
No, she's a small girl.
plus
So let's just say
tan x. If y equals to ln sec x plus tan x, when y is absolute value is less than 5/2, show that y dx is cos y. So let's find y dx. Absolutely, dy dx here is what? Absolutely, dy dx here is differentiate what's inside the bracket. That's dy dx is actually sec x. Do you agree with me that dy dx is sec x? Do you agree? That if I differentiate this, I'll get sec x. Do you agree?
When there's encouragement,
Are you there? Okay. So if dy dx is this sec x, so what we are trying to prove now is that one should have sec x is actually the same thing as cos y. So that's what we are trying to prove. Sorry, hold on. 1 minute. So okay, moving on. So what you want to show actually is sec x is actually equals to cos y. So how do you go about that? Now we are going to start from this guy. So we're going to start from here. So basically from here I have exponential y to be equal to what? If I take exponent of both sides, it is equal to sec x plus tan x, right? Right? Hello, are you there? So exponential y is this. So how do you now prove that sec x is cos y? So let me put at the corner. Let me put at one corner here. We want to prove that sec x is the same thing as cos y. And so let's have it at the back of our mind. We just go and write at the back of our example. You know that example booklet, it has one page at the back that is for rough work. So that rough work, we just go and put that recall that cos y is exponential y plus exponential minus y all over 2. So all you just need to try and get to this, to go and get to this point. So if you can try and get to this point, then you have solved your problem. So how can we get to this point? I have exponential y already. So that means that okay, that means wait, what am I missing? I want to do that sec x is equal to cos y. This is sec x now. This is sec x now. So okay. So if I have this guy now, what do you think you can do? What do you think you can do? What do you think you can do? So if I do 1 over this, I have exponential minus 1, but that wouldn't solve my problem. So that wouldn't solve my problem. If I write this one as in terms of okay, so let me do something like this. So let me do something like this. Now, you know, from here I will say that I will have exponential y minus tan x is equal to sec x. It's equal to sec x, right? Okay. But if I do this now, how is it going to help my life? Think about it. So how is it going to help my life? So how is it going to help my life? So if I do 1 over exponential minus y, I have 1 over this. Okay. Should we follow that? Should we follow that method? Because these things before, but I can't just remember the way I went about it. So I'm looking for the shortest thing I can do to just solve this problem, you know. So to just solve this problem. So I think, okay, let's try and go that way. So if exponential y is this, it means exponential minus y will be actually sorry, not this. It will be actually 1 over sec x plus tan x. So actually I don't want to go this way, but let's see how it goes. Okay, so if I do exponential y plus exponential minus y, so it means I have to add these two together. So if I add these two together, let's do subtract and minus. So LCM is sec x plus tan x, obviously. Sec x plus tan x. Okay. So I have to multiply sec x plus tan x times sec x plus tan x here. So that will be sec squared x plus 2 sec x tan x then plus what? Tan squared x abi, then plus 1, right? So this is sec squared x plus 2 sec x tan x. So our answer has come out. If you are seeing it, our answer has come out already. Now tan squared x plus 1 is actually the same thing as what? Sec squared x, right? By trig identity. So everything all over sec x plus tan x. So, and this is equals to sec squared x plus sec squared x, that's 2 sec squared x. So let me just collect like them. 2 sec x is common. I will have into bracket what? Sec x plus what? Plus tan x, right? Then all over what? All over sec x plus tan x. And this is what you are using. You are saying exponential y plus what? Exponential minus y is equals to this. So you can see that this one we cancel this one, right? Are you with me?
Yeah.
So if I divide both sides by 2, I will have exponential y plus exponential minus y all over 2 is now equal to what? Sec x. And this is actually the same thing as what? Cos y. So from that, you have been able to what? Say that sec x is the same thing as what? Cos y. So the y dx is actually equals to cos y. Do you understand? Hello, do you understand? Okay, so let's look at the second part of the question again. So the second part is saying that, and hence or otherwise, you should find integral of 1 all over cos y dy. So let's try and see what we can do with that. So hence otherwise, or what do you say? Integral of 1 over cos y dy. So if you are given something like this, you already know that they want you to go from somewhere to one thing later. So you know that they gave you what? They gave you y to be what? Ln what? Sec x plus tan x. And don't forget that what? That dy is what? Actually the same thing as what? Sec x, right?
Yes.
And this is the same thing as what? Cos y, right? Right?
Yeah.
So having that in mind now, I can say okay, should I do that? Should I do that? No. Nothing is coming to my head, but it's not proper. So we are going to integrate 1 over cos y dy, and Sorry. What am I writing now? I am writing like this. Don't forget that the y over dx is the one that is what? Is the one that is what? Cos y. Now, if I cross multiply, like I do something like this, I'm going to have, like, I can have, this is going to give me that the y over what? Cos y is equal to what? Is equal to what? Dx, right? So if I use that logic here, you know, in this equation, this actually seems to be saying integral of what? Dy over what? Over cos y, right? So instead of me saying integral of dy over cos y, I'll say this is equal to what? Integral of what? Dx. Are you with me? Since the y over cos y is dx, so what is the integral of dx? X, then you put what? Plus c. So you just put x plus c. So having that in mind, and you know that your y is ln sec x plus tan x, blah 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 blah. All these things, it's just to substitute for the value of x here. You know, your integrals in terms of y, but you are able to convert it to x. So answer is x plus c. You don't even need to stress yourself again. So that's just the solution to that. So what else? The next one in line. You're not told to what? You're told to also evaluate integral of 1 over cos x dx correct to 3 significant figures. To evaluate 1 over cos x dx correct answer to 3 significant figures. So in this case, what I just need to do is there's no stress, you know, there's no stress. So we are going to integrate 1 over cos x dx from which interval again? From 1 to 2. You know, the first case they give you is 1 over cos y dy. So there's still no stress. So what I will just do is this. Without loss of generality, you know, without loss of generality. So I'll just take 1 over cos x as, so wherever there is x in this illustration I have here, if I put y there, so if I say my x is equal to ln sec y plus tan y, so my dx is equal to this, then so what I'll just have here is that I'll have so I'm going to have something like, let me see before I go and do nonsense. So I have dx. So if I change everything, so if I change where I have y to x and x to y, I'm going to have dx dy to be equal to what? Sec y, which will also be equal to what? Cos x. So in this case, instead of me integrate 1 over cos x dx, I will have integral from 1 to 2 of dy. So this is going to, now, so in this case, this your interval here is going to change because this your interval here is for x. So you are going to convert your interval to y. So how does your x links to y? So don't forget, you are changing everything that relates to y here to x and everything that relates to x here to what? To your y. So you are saying that x is equal to what? Ln sec y, right? Minus, oh sorry, plus tan y tan y, yeah, in tan y, and your variable, your limit here is corresponding to what? To x. So your limit here is corresponding to x. So I think this is going to give me some kind of issue here. I'm able to convert this guy to stuff like that. So before I do that, this is actually y, but the limit here, instead of it to be 1 to 2, the limit here is going to be in terms of, so instead of having y from 1 to 2, I have to write y in terms of x for me to take this limit, because this limit is for x. So in this case, so what I need is to make y the subject of the formula here, so that I can substitute it here in terms of x. So from here I can say, okay, exponential x is sec y plus tan y. Was it inside this place I did that? Okay, this is where I did that logic. Yes, exactly. So exactly. So I can just use this. Are you with me? I can just use this logic. Sure you get. So I already have that what cos y is the same thing as sec x. So instead of me to do it from scratch again. So that means here that what? That y. But before I did this, I already changed y to x and x to y. So instead of me have cos y equals to sec x. So in this case, I will say cos x is equals to sec y. So that I can now say, even from here, I can even put the logic here. But since you are using ends, the question said also from this one that we have proved, also evaluate this. So what I will have done before, I'll just say since cos x is sec y, then it means 1 over cos x is going to be 1 over sec y, and 1 over sec y is actually cos y. So what I'll just do is here, so okay, the thing is that I can't just put cos y here because it is related to x, so I cannot do that. So from here I'll substitute for y. So if cos x is equal to sec y, that means y is arc sec. Can you find arc sec in your, I don't think you can find arc sec in your calculator. I don't think you can find that. So what you just need to do is, don't do arc sec instead of arc sec. So yeah, just use this one. Take the inverse of both of them, so that you have 1 over cos x to be what? Cos y. So if we have that, that means you are saying that cos y is equals to 1 over cos x is actually sec x, like the hyperbolic sec, right?
Yeah.
So that y will now be what? Arc cos of sec x. So this is going to be arc cos of sec x. Yeah. So is this guy that you now come and substitute here before putting your limit. So you now say this is equals to, instead of me having y, I'll have arc cos of sec x. So arc cos of sec x. So taking limit from 1 to what? To 2. So when x is 2 minus when x is 1. So anything you get, you just as it's written here, convert to 3 significant figures. So that ends the question. Is that well understood, Sha? Benjamin, are you there? I didn't hear that. What did you say? Your network is breaking. Your voice is breaking. Okay. So next week we are still going to talk about. I said next week. On Wednesday we are still going to talk about hyperbolic functions. So next week it should be more of you just select the question that we would like us to tackle. Then that's what we are going to do next week basically. So we are going to do case study as that regards. So that's what we use as case study, and we'll move on to the next topic next week. Do you understand? So all right. So bye for today. See you on Wednesday. You said you what?